we've already identified as matter as something that has both mass and volume. And now we're going to look at what are some specific characteristics of different types of matter that help us to identify what that matter is. And then how do we distinguish the difference between a physical change and a chemical change? And so let's take a look starting with physical properties. Physical properties are things like shape, odor, color, density, solubility, and melting point. Now, each of these gives us some specific details about that piece of matter so we can identify it as being what it is. And some of these, like shape, odor, color, you already understand those, that it doesn't take a lot of explanation. But some of these other words, like density, we've looked at that density is the amount of matter there is in a given space. And so we know, for example, that the density of iron is a very specific number, and that as a result, if we find something with that density, that we can identify it as being iron. Or the solubility, we know that like sugar and salt and things like this, they dissolve in water, and so we can help identify what those things are. Or the melting point, for example, we know the melting point of ice is 0 degrees Celsius, and so we're able to identify something by when, at what temperature it melts, by knowing that, okay, we know that that is H2O or water because it melted at that specific temperature. And so these are some of those physical properties that help us identify matter as being a specific type of matter. Chemical properties are a little bit different. They're going to deal with how that matter kind of reacts with other things. And so things like acidity, basicity, whether it's an acid or a base, we'll talk about that later in this semester. Right now you just need to be able to recognize that as a chemical property. Combustibility, which is the measure of its ability to ignite or burn, and so how easily something burns would be that. Or reactivity, how easily something reacts chemically with another substance. And so you notice in each of these that there's something we're looking at kind of on a chemical level or even a molecular level versus just a physical outward appearance type of level. And when we come to these, these impact the way that these different pieces of matter react with the world around them. And so in addition to understanding and knowing what these chemical properties are, and you do need to know what they are and what category they fit in, and in the lab have you make a T-chart and list these on each side. And so if you've not done that, I encourage you to use these videos to be able to help you go back and look at your notes and make sure you have those things in there. But it also affects how it reacts with things around it. And so we have both physical and chemical properties, and we also have physical and chemical changes that happen in matter. So when it comes to physical changes are things that like changing the state of matter from a solid to a liquid to a gas. That substance is still the same substance. And so if we look at water again, the chemical makeup of water is 2 hydrogens, 1 oxygen, H2O. And so whether it's in solid form as ice, it's H2O. If it's in a liquid form as water, it's H2O. If it's in a gas form as steam, it's still H2O. And so it didn't change what the substance is, it's just changing what state of matter it's in. Something like a change in color. And so if you just take something and you put a layer of paint over top of it, that could be a physical change. Changing the temperature of something, again, and just making it go up or down, that could be a physical change. Changing the shape of something, so if you take a piece of clay and you mold it, then that would be a physical change. Changing the texture of something, so if you took a piece of wood and you rubbed sandpaper over it, you change the texture of it, but it would still be wood. And so in each one of these physical changes, it's not changing what the substance is, it's just changing maybe what it looks like. And so it's a change in the form or appearance of a substance. It does not change it into anything new. And we're talking about on a molecular level. It's not changing what it is on a molecular level, down to the kind of the identifying what that substance is. And so examples would be things like whipping eggs, boiling water, dissolving sugar, dicing up, cutting up vegetables. Each one of those things is changing the form or the shape, but not what the substance is. It's still the same substance. Chemical changes are a little bit different. Chemical changes are when 2 or more substances join to form a new substance with new chemical properties. And so these would be things like iron rusting or gas burning, eggs cooking, bread rising. All of these things. So if you think of bread, you could mix all the ingredients into a bowl together, and when you add that heat, it changes into something completely different. It's no longer the flour and the water and the different elements, the oil or the butter or whatever you're using in there. Now it's something completely new that is much better to eat than it was when it was in the form, just everything mixed together in the bowl. The key thing to remember between physical and chemical changes is that in a chemical change, a new substance is formed with totally new properties. And so we'll look at the chemical reactions and how do we figure out what those are going to be and balancing those out in the future. But now you need to understand that these chemical reactions, like the one we see on the screen here, occurs when these two different substances, in this case CH4 and 2O2, you see that on the left-hand side, and it becomes something completely new. It changes into a new substance. Bonds are broken and new bonds are formed. And so chemical changes, there's a few ways that we can identify that a chemical change has taken place. One, an unexpected color change. Now earlier I said a color change could be a physical property. Now if I'm painting a wall, then I'm expecting that color change, that I'm doing it purposefully. I'm just putting paint on top of something. The wall is still made of the same stuff. I just put a new coat of paint on top. This is when a color change happens kind of unexpectedly. We combine two chemicals together, and that chemical reaction radiate light differently and results in new colors. So examples of this would be like fireworks or the leaves on the trees changing color. And so that term unexpected doesn't mean that we don't know that it might happen, but it just means that we didn't do anything directly to change the color. The combination and the chemical reactions are what did that. Another way to know if a chemical change has taken place is an unexpected temperature change. And so I'm using this term unexpected in the same way. That it's not that we put heat on something and the temperature rose, or we put it in the freezer and the temperature cooled down, but it's the combination of two chemicals or two substances that cause that temperature change to happen. During the chemical bond, energy is released and absorbed, making their surrounders hotter or colder. And so the examples of this are adding baking soda to vinegar. It causes the temperature to decrease in the vinegar, or body temperature increasing to fight infection. And so there's something that's going on there internally, chemically, that's causing that to happen. You see the picture up there on the board, those ice packs where you kind of punch it and it becomes cold. That would be an example of an unexpected temperature change. Another one is combustion or burning. If something blows up, catches on fire, we know that a chemical change has taken place. A chemical reaction between the two substances, usually including oxygen, is giving off a heat or a light. This is a permanent change and it can't be undone. So you think of a match burning. It's that permanent change that can't go back to the way that it was. Examples are wood burning or a candle or rusting on a piece of metal. Though we can cut away at the rust in that example, we can't make that rust change back into iron. Another one is a precipitate forms. A precipitate is just a solid forms of some sort. It's a solid suddenly appears in the solution and settles to the bottom. And so this isn't like freezing and we make a liquid into a solid, but this is again when we combine two chemicals and a solid kind of suddenly appears as a result of that. And so an example of this would be milk going bad. If you've ever opened up that carton and you begin to pour the milk and chunks come out, this would be a precipitate that forms. Or bathtub rings as the water begins to react with the metal of the tub, and you see the ring that forms there. Final one that we're going to talk about is a chemical changes. Bubbles form when the gas is released. And so these bubbles begin to form, gas is released, and we see that chemical change happening. An example of this might be Alka-Seltzer, if you've ever used an Alka-Seltzer tablet, or bubbles in a soda. And there's two different ways that we classify kind of this energy happen. If you notice in all of these, bubbles form, precipitate forms, combustion happens, or fire, temperature changes, color changes. In each one of these, there's two different ways that we identify this. One is that we identify it as an exothermic reaction. Now that thermic is thermal energy, that's heat, and so exo, it's exiting heat, and so heat is exiting out of this reaction. And so that would be something like fire, and so as that fire reacts, heat is leaving that reaction. Fireworks would be an example of this as heat leaves that. The other way that we classify it is endothermic. Again, that word thermic means heat, it's heat energy. Endo is that heat is going into the substance as that reaction is happening. And so baking cake or bread would be an example of it. The bread doesn't explode in the oven, that heat goes into the bread, causing that chemical reaction to happen. And so here I've just got a simple piece of paper. Now I can take this paper and I can ball it up, and I can ball it up and make it quite compact. But if I were to take this paper and I kind of fold it back up, and it might not look as pretty as it did before, it's still a piece of paper. That chemically, this thing's exactly the same as what it was. It's just a little bit more wrinkled now. I could even take it and I could kind of fold it and make it into a paper airplane. And again, we all know that I'm not making it into a real airplane. It's just a paper airplane. So just like the paper when I crumpled it up, it's staying the same substance. It's the same type of matter. I've just made it look like something different. Right? It hasn't actually changed what it is. And in fact, if I wanted to change it back, well, once again, I could do that quite easily and change it back into just a sheet of paper. Now it's a little bit more worn out, it's a little bit older looking, but it's still a piece of paper. Those are all examples of physical changes. That while I can change the shape, I can change the form, I can fold it up, I can ball it up, I can do all these different things, it doesn't actually change what it is. It's still a sheet of paper. However, if I want to take a lighter and I light this piece of paper on fire, well, now it's something different that's happening. You notice that as this piece of paper burns, that it's going to be really hard to turn it back into something. You know, it's going to permanently be different. There's no way to make the rest of that show back up. And so as we're looking at physical and chemical changes, I want you to keep that in mind. Could I easily reverse this change? Or is it permanently something different than what it was? So this is an easy example, easy illustration to see the difference between these types of changes. You might be able to see the ash that's kind of falling to the ground as this piece of paper burns. It's no longer going to be good to write on. It's no longer going to be good to make paper airplanes out of. Now I've got, maybe a quarter of a piece of paper where I once had a full sheet. It's something totally different. And so as we look at physical and chemical reactions, the key thing to be able to tell the difference is this. If a totally new substance has formed with new chemical properties, that's a chemical reaction. If it's the same substance that just looks different, that's a physical reaction or physical change. And so new substance, chemical change. Same substance, new look, physical change. And so you're going to need to know these physical and chemical properties as well as the physical and chemical changes. If you've not completed the station lab, it's going to help you walk through these things to make sure that you understand. And so when we have that quiz and that test on this subject, you're going to be responsible for knowing and being able to apply these principles. So if you have any questions, you need to reach out, you need to ask, and so you make sure you get these things down.